Welcome back to our YouTube channel, Mechanical Engineering Exams Made Simple. Friends, in this video, let us see questions from production and materials, which is the 8th topic in your syllabus for your Tspsc Amvi Automobile Engineering optional paper. That is second paper for your examination. These are the very good bits from production and materials. You can expect at least from each topic, there are 8 topics, you can expect at least 15 to 18 questions from each topic minimum. So definitely, if you go by the previous papers also, you see that at least 15 to 20 questions were asked from production and materials, and especially this particular topic, which is your iron carbon equilibrium diagram, is a very important topic. You can expect 1 or 2 questions minimum from this particular topic. Even if you get one question, that would be a great thing. The microstructure composition of perlite for an iron carbide diagram consists of. So he is asking about the perlite microstructure. So what it is going to consist of? Is it carbon dissolved in alpha iron having a body BCC structure, body centered cubic structure, carbon dissolved in gamma iron having an FCC face centered cubic structure, a mixture of body centered alpha iron and face centered gamma iron, or carbon dissolved in body centered alpha iron and iron carbide. So what is the correct answer? Actually friends, here the correct answer is austenite is actually, if you observe, it is unstable below 723 degrees centigrade, which is your eutectoid temperature. So carbon dissolves in alpha iron and cementite and known as perlite, which has body centered cubic structure. So in the body centered cubic structure, we know that there are 8 corner atoms in the unit cell and 1 body center atom. So the correct answer is D. Eutectic reaction for iron carbon system occurs at. So what is the correct answer? It is eutectic reaction occurs at 1130 degrees centigrade and eutectoid reaction occurs at 723 degrees centigrade. Others are insignificant as far as these phase reactions or solid solution reactions are considered, like peritectic, eutectic, eutectoid, etc. Okay friends. So anyhow, so remember 723 is the eutectoid temperature, 1130 is the eutectic temperature. Okay, so the correct answer is C, eutectic reaction. So based upon 2 solids gives rise to liquid or liquid plus solid gives rise to solid, something like that. So these reactions, phase reactions, are categorized like eutectic, peritectoid, eutectoid, etc. reactions. Which one of the following sets of constituents is expected in equilibrium cooling of a hypereutectoid steel from austenitic state? What is the correct answer? Let us see the correct answer for this. So is it that ferrite and perlite? Is it that cementite and perlite? Is it that ferrite and bainite? Is it that cementite and martensite? So generally friends, bainite and martensite are not going to come into picture. So you can easily eliminate C and D. Let us see the correct answer. The answer for this is cementite and perlite. So your perlite is a mixture of ferrite and cementite. The correct answer is B. A given steel test specimen is studied under metrological microscope. Magnification used is 100 times. X means 100 times. In the different phases are observed. One of them is Fe3C, that is iron carbide. The observed phase Fe3C is also known as. So what is the other name for iron carbide? Is it ferrite? Is it cementite? Is it austenite or martensite? Martensite is the hardest phase friends. Austenite is also called gamma iron. Ferrite is also called alpha iron. So what is the correct answer for this? The correct answer for this is cementite. So iron carbide is also known as cementite. So your iron carbon diagram, sometimes also called iron carbide diagram. Iron carbide here means cementite. Now heating the hypoeutectoid steels at 30 degrees above the upper critical temperature line, soaking at the temperature means keeping at the temperature, and then cooling slowly to room temperature to form a perlite and ferrite structure. So this particular mixture of perlite and ferrite is known as what? Okay, so this particular process, right? Hardening or you are normalizing or tempering or annealing. So this particular actually friends, it is misprinted actually. There are some options are to be there. So now let us see directly answer this particular question. The combination of perlite and ferrite structure is known as heating and so heating and slow cooling is the process of annealing. Okay friends, okay. So definitely once again let us correct ourselves. So this is a heat treatment process. So it is going to give perlite and ferrite for the heating, then holding and cooling operation, which is normally there in any heat treatment operation. It is going to result in annealing. So this process is called annealing. Hardening is required to, is normally done to increase the hardness. So here in the hardening, the cooling rate is very fast and the cooling medium used is normally salt bath. Normalizing, it is something like annealing, but tempering is normally this operation is conducted after the hardening to relieve any internal stresses because of the hardening process, which is going to result in brittle nature of the microstructure. So the correct answer is annealing. In a eutectic system, two elements are completely. So is it that they are insoluble in solid and liquid state, or soluble in liquid state, or soluble in solid state, or insoluble in liquid state? What is the correct answer? It is actually, so your eutectic reaction is given by liquid on cooling and heating. Liquid on cooling is going to give alpha plus beta, and alpha plus beta on heating are going to result in liquid. So what are these? So in eutectic system, the two elements are completely. So the correct answer is alpha beta are the solid phases. So L is the liquid phase. So you can easily see that the correct answer is soluble in liquid state. Now, martensite is supersaturated solution of carbon in. Martensite is a very hard phase, friends. The microstructure will be brittle, too brittle, and very hard phase out of all the phases present in the iron carbon diagram, like sorbite, trusite, ferrite, cementite, perlite, austenite, ferrite, etc. of all the phases, and it is actually not shown on your iron carbon diagram. So this is a very hard and brittle phase, martensite. So this is a supersaturated solution of carbon in which iron he is asking. Is it alpha iron, that is ferrite, or gamma iron, or austenite, or delta iron, or beta iron? I think there is no iron like beta iron. There are three irons like alpha iron, gamma iron, and delta iron. What is the correct answer for this? The correct answer for this is A, alpha iron. Right? TTT diagram indicates the time and temperature transformation of what? The time and temperature transformation curve corresponds to the start and finish of transformations which extend into the range of temperatures where austenite transforms to different microstructures. The correct answer is austenite. TTT, time, temperature and transformation. Transformation of the phases with respect to temperature on cooling and heating, which is going to be time dependent, or time, cooling time and heating time. There are basically three stages in any heat treatment operation, that is heating, then holding for some time, heating above some temperature, maybe above recrystallization temperature or below recrystallization temperature, and holding for some time, and then cooling to certain temperature or room temperature, let us say. So the correct answer is D. Let us see some missed questions here, friends. Perlite consists of what? Perlite consists of, is it 6.67% carbon and 93.33% ferrite, or 13% iron and 87% cementite, or is it that 13% carbon and 87% ferrite, or is it that finally 13% cementite and 87% ferrite? So what is this? It is actually, friends, perlite is a lamellar structure. So here we are going to talk about the lamellar structure of the your microstructure of the faces, structure of the faces. So perlite will be having, if you observe under a microscope, it will be having like a lamina type of structure. It is also called lamellar structure. It is basically composed of alternating layers of alpha ferrite, that means alpha iron 87% and cementite 13%. So but how this is going to be calculated? So ferrite is, the percentage of ferrite is obtained from those percentage of carbon, right, like 6.7 percentage. So your iron carbon diagram is drawn for a maximum of 6.67 percentage of carbon in iron. So ferrite is equal to 6. So you have to consider two percentages, 6.67 and 0.8 percentages. Okay, right. So ferrite percentage is equal to 6.67 minus 0.8. So what is this 0.8 percentage? It is hypoeutectoid. So it is the percentage of carbon according to which we can categorize steels are as hypoeutectoid steels and hypereutectoid steels. If any steel is having less the percentage of carbon less than 0.8%, it is called hypoeutectoid steels. If any steel having more than 0.8 percentage of carbon remaining iron, it is known as hypereutectoid steel. So the ferrite percentage will be obtained like 6.67 minus 0.8 by 6.67 minus 0.008. It is the solubility. That means that is going to give approximately 88.1 percentage, and cementite is equal to 0.8 minus 0.008 by 6.67 minus 0.008. So that is going to come around 11.9 or 12 percentage. So approximately we can take 87% of ferrite and 13% of cementite as the correct answer. So your answer is D. 13% is cementite, 87% is ferrite. Right, friends? You can easily remember this like this, right? C comes after F. Yes or no? That means, F comes after C. So C is before F. So that will be lesser than, let us say, F. So definitely the percentage of cementite will be lesser in 100% compared to the more percentage of 87% ferrite. So that's how you can easily remember to avoid the confusion whether it is 87% cementite and 13% your 87% cementite and 13% ferrite, like that. So you can sometimes make some tricks for remembering certain questions which are little confusing sometimes. Now during peritectic solidification, one liquid, what is going to happen in the peritectic solidification? So there is something reaction called peritectic reaction. So in that what happens, he is asking, combines with one solid to form a second new solid, solidifies into two different solids, or forms one solid, or form one solid and another liquid. So let us see the correct answer. The correct answer is liquid is going to be transformed into liquid plus alpha. Liquid plus solid is going to give another solid. Liquid plus solid is going to give another solid. So the correct answer is A. Right. Okay, friends. So coming to the ninth question, we will discuss more on martensite. So martensite is actually, it's a saturated solution of carbon and alpha iron that is formed when steel is cooled so rapidly at a rate greater than the critical cooling rate. Hence, during changing from austenite, the perlite is suppressed. So the formation of perlite is suppressed because it is not having the time. Because in very short time, lot of temperature drop is going to take place. That's how we can describe a faster cooling process. Right. So because this cooling rate is more than the critical cooling rate, the formation of perlite phase is suppressed. So now because of that, so formation of perlite is suppressed, thus responsible for the formation of martensite. So remember that it is a very hard and brittle phase of all the phases, and it is not shown on our iron carbon diagram, iron carbon diagram, equilibrium diagram. It's also called iron carbon diagram or iron carbide equilibrium diagram. Why we are going to use the term equilibrium? That means you are heating sometimes and then you are cooling. So during heating and cooling, if you are going to change the percentage of carbon in iron, what are the different phases are formed at a particular composition and a particular temperature. That is going to be given by, this information is going to be given by a iron carbon or iron carbide equilibrium diagram. Okay friends. So in this video we have seen some beautiful questions from your iron carbide equilibrium diagram from your production and materials. In the next video we are going to meet with some more beautiful excellent questions for your AMV examination for automobile engineering second paper. And friends, news is that the examination is going to be postponed because of the leakages and all these things. Okay friends, so this we can say actually we did not expect that leakages would take place. Had the examination been over by April 23, all the candidates would have been very happy, but it is not in our hands friends. It has happened, we cannot do anything, we are helpless. I think the examination might be conducted most probably after the group 1 prelims. The date of group 1 prelims is also has been cancelled, and the date for group 1 prelims is tentatively fixed at June 13. So in any case our examination AMVI is not going to be conducted before April 33 or April 33, the date given by the Tspsc. So we will be having some more time friends. Okay, so actually this should not happen. Even I am of the feeling that because the serious candidates are really worried about what is happening. Okay friends, but then some people, for some people it may be blessing in disguise. If some of you are interested to use this particular additional time you are going to get for your coaching, you can contact me online coaching. You can contact me on 9912507633 and you can mail me at sridhar.people@gmail.com. We will meet in the next video very shortly. All the best.